My name is Peter Ditender. I'm a Microsoft technical trainer from Redmond, Washington. I've been a trainer for a bit more than 14 years, but within the Microsoft role, close to 5 years now. The trainings that I typically deliver are Azure architecting, developing together with DevOps, and now moving more to AI and Copilot. In this session 6, we'll talk about evaluating your performance. We have our custom copilots running out of prompt flow, and we're going to optimize the performance of them. Let's get started. Awesome. We have our AI Studio up and running with all the components that I talked about in the previous sections. And eventually, in the last topic, we discussed how to integrate prompt flows, how to use them, how to configure them, and eventually how to test them as well. From here, I'm slightly going back to one of the topics I discussed in the first section of this training, and it's about optimizing performance. So in this section, it's all about evaluating the performance. Where performance in this context is not really about performance in a speed context. How fast is my chat getting completed? How fast do I get a response? Although I would say it's probably one part of the benefit of using the tool. If it's running smooth, if it's responding fast, and on top of that, the answer is accurate, that's like the ultimate dream solution. But going back to the model performance that I positioned earlier, it's really about validating what kind of language model do I have. And remember, we got a whole list of language models to choose from and deploy them out of AI Studio. And now you're going to run testing. Which of the language models are the ones that I need for the characteristics of my solution? Am I using the OpenAI GPT ones? Am I using the Meta Llama ones? Am I using DALL-E because you want image generation and whatnot? So that's the first step in your decision making. Next to that, you're also going to look into how performing is that model from a usage perspective. Meaning, what is the accuracy? And we talked about all this already, right? So what we're mainly zooming in on this, without repeating everything from the benchmarking, is really to evaluate and test the success factor, I would say, of your solutioning. You got the large language model. In the meantime, you also have your flows out of prompt flow as one of the examples. You're going to bring in your Python code, and you're going to start running your tests. You're going to rely on the built-in benchmarking out of the AI Studio to evaluate, to really test, and hopefully flag as a successful run out of your custom Copilot solutioning. So again, we have 4 different sections here. We got accuracy, already talked about this. It's where it's going to try and give you the most accurate answer. When you run a benchmark against fluency, it's closer to how does my natural language processing aspect of the large language model, how fluent in like a human-alike language is the answer formulated. It can be technically accurate, like it's factual data, it's 100% correct, but the way we provide that answer is not 100% accurate. You could almost say like the answer comes from a 2-year-old kid or a 20-year-old junior person, where obviously the answer might be the same thing, but the way they use their language is probably slightly or majorly different. And then coherence is where, again, it's going to look at how smooth, how fluent is the response. Like again, mimicking almost close to human-alike language. And then the other one, but that's specifically for the OpenAI large language models, where in this case it's the GPT similarity, where you're going to find out, like using the groundness, using the different GPT language models, what's the difference between GPT-2, GPT 3.5, 3.5 Turbo, 4, and then maybe 4.0. I'm going to bring in a demo where in the previous sections, well, one of the first sections actually, when we touched on optimizing performance, already briefly touched on the benchmarking, but I told you that at this time we would zoom in on that a little bit more. And that's exactly what this demo is going to be about. So let's move on with the next demo, where it's all about model benchmarks. Now, I talked about this a little bit in part 1, session 1, but I told you that I wanted to add a little bit more context. Now, I've been playing with different models. I used different GPT ones. I used GPT 3.5, used GPT 4, used text embedding. We integrated Meta Llama language. I didn't do anything with some of the other flavors like Mistral. I didn't do anything with Databricks and so many other. But in the end, one of the core steps, I would say, for you as a AI developer or when you're developing custom copilots is deciding which of the available large language models are recommended for the purpose of my copilot. So what I showed you before is the model benchmark. It's the section here in our getting started because honestly, I think this is one of the first things you should actually go through. I'm showing you a little bit more after going through all the other content because obviously there's nothing wrong in going back and forth. So you might have worked with your custom models. You're going to deploy them. You're going to manipulate them. We talked about fine-tuning, talked about prompts and all that fun, cool stuff. Where now you go like, well, we've been using it for a while and we're not 100% happy with the results of our copilot. So now maybe it's about time to revise the technical components or even staying within the same large language model because the APIs, the versions, if you want, in the backend are actually getting updated continuously. So in short, in our model benchmark out of Azure AI, it allows you to compare benchmarks across different models, across different data sets available within the industry. And you're going to decide which ones are meeting your business scenario. So the starting point is select the large language models that you want. You can use LLMs, you can use the small ones, you can use the embeddings, so it's not really picky on anything. We have model accuracy. I already talked about this before. So accuracy really means that how accurate is the data compared to the prompt that I'm firing off. Like all the examples I shared, tell me something about London, tell me something about the Prime Minister in the UK, moving it a bit more into our travel agent, travel assistant option, and really using that scoping. Where I'm asking a question about, tell me something about New York, like where to stay. And yes, the information was quite accurate, partly because it was based on our own data set, but it doesn't mean that the large language model that's going to use that index is capable of picking it up and accurately responding. So that's what you can filter, fine-tune from here. Without going too much in detail on all the possible language models, by the way, let me filter this maybe a little bit, where I'm going to use the collection from OpenAI. There we go, looks at least a little bit nicer. I'm going to move this out of the way. And what it shows me here is the different GPT versions. So this is 3.5 Turbo, this is GPT-4, and I guess those are the two prime ones with a few different variations out of the versioning. Now simplifying it a bit, how to interpret the diagram, GPT-3 all the way here to the left has a scoring of 0.75. So it does a pretty okay job in detecting that human-alike level. Well, now if I jump to GPT-4, it's all the way moving up to like 0.85, I guess, or 87 even, which means it's more capable of providing an accuracy level, like recognizing the prompt in a better way than 3.5. And again, I don't want to break down 3.5 because that was already doing a pretty impressive job. Now, any of this, it's mainly like, yes, it works, or it works better, or it works outstanding, and that's really one of the scenarios. You can filter more parameters, so we can move down, where now we have the coherence. And as you can see here, coherence evaluates how well that language model can produce output that looks, feels smooth, reads natural, as close resembling human-like language. Where using about the same content, because again, I filtered on GPT, there is a slight difference between GPT-4 and GPT-3.5. The challenge I had initially, and that's why I like to point it out, is that now all of a sudden, we're still in the same view, but the order of the models has been flipped around. So in the previous one, GPT-3.5 was on the left side, GPT-4 on the right-hand side, and now it's the other way around. So initially, I actually didn't really understand the outcome, like, oh, wait a minute, so GPT-3 is better in this than GPT-4, but it's because the diagram is actually flipped around. And then obviously from here, you can do the same for the other benchmark components. That's pretty much it on benchmarking. There's a lot more you can do with this, but we still have a few other things to cover, and we're getting close to the deadlines of our virtual training day presentation time. So with that, let's go back to our presentation and closing with the last couple of words. Now, the benchmarking demo showed you a lot of different numbers. I hope my explanations helped you in really understanding why, first of all, you should do benchmarking and how to do them. But again, in the end, don't forget the goal of having benchmarks in the first place, and that's helping you evaluating what kind of language, what kind of scenario you want to use for your custom copilot. Testing, is it really the solution I'm looking for? That's the idea. Now, one of the other options you have besides benchmarking is using a manual evaluation. Now, there's a few screenshots here on the slide, and I could imagine that it's not all that clear. So guess what? There's a demo coming up. But in short, what we're doing is allowing you as the solution developer to bring in your own manual context by creating some sample input, again, like sample prompts, you could say, running it through the system, running, for example, a prompt flow and deciding, like based on the input, I'm going to integrate my custom data and how accurate is the outcome. So that's one option. Now, in short, how to do that, how to measure all that, in the end, it's again about numbers. That's also why that benchmark dashboard is so important. So touching a bit on the metrics here, what we're going to do is integrating a test data set. Remember, in our flow process, we talked about initializing it, next to that, testing it, evaluating it, validating it, using a small data set. Once you have your data set, you're going to create a more complex scenario where now we're not using the manual approach anymore, but we're going to use an automated evaluation. Next to that, we're going to select a flow. You can build one flow, you can add all the variants, you can run multiple flows, and you're going to define the metrics that you want to use during your evaluation. From there, obviously, you're going to run the test, you're going to run the evaluation flow, and you're going to wait for the results. So we have the pre-built, pre-inspired benchmark numbers and the results from that, but nothing blocks you from doing the same against your own data using the manual testing or using the automated testing. Enough talking about it, because it's a lot more interesting to show you how this actually works from within the AI Studio. So with that, let's jump to another little short demo and really showing you how to use the evaluation, allowing you to assess and compare the performance of your AI applications. And again, the performance doesn't mean how fast it's actually flowing. It's about the other components, knowing how accurate it is, about responding. Now, to get you a little bit back in our scenario, we have our system message where we told our AI environment, like you're the travel assistant. And as I told you in previous demos already, it's nothing too much to validate. Is my system message okay? Is it getting picked up okay? And that's what I did here with what can you do? And it's telling me like, well, I am the travel agent. So that's pretty much it. So from here, we're gonna move over to evaluate. And it's right up here in our chat playground, where you have two different options. You can do a manual review responding to test data, and then later on you could also do the same from an automated perspective. So for now, I'm going to show you manual. And the way it works is that you still have some options where you can manipulate the system message. You have the different models to choose from. You can play with the chat parameters. I'm not going to worry about all that for now. But important with the manual evaluation is that you're going to provide like a handful of inputs that you're going to review as the output. So I'm going to copy and paste a couple of questions from my sample document here, where one question is, can you provide a list of top-rated budget hotels in Rome? I'm going to add another one where I'm going back to New York and asking for any vegan-friendly restaurants. I'm going to make it a little bit more complex in another scenario where I'm asking to help me building a 7-day agenda, calendar, itinerary, if you want, for a family vacation in Orlando, Florida. We're going to make it a little bit romantic and asking some assistance with yet another input. Planning a surprise honeymoon trip And I guess that's good for now. I'm going to run it. And what it's going to do here is running some testing. So it's going to provide information, and as you can see here, it didn't pick up my previously configured system message. As you can imagine, Peter told you multiple times, I'm not that good in applying changes, so that's where it's not doing a 100% job as expected, but nevertheless, it's actually still doing the evaluation. Now, the idea about the evaluation is that based on the prompt, can you provide a list of top-rated budget hotels? It's now going to tell me like, well, I don't have real-time information, but I can still make some suggestions. If you think that this is a positive evaluation, like it's doing a good job, you can actually provide a ranking like, woohoo, thumbs up, and it looks like a pretty accurate output. And obviously the same for the other ones. So looking for vegan options, it's providing a nice, good list. It's doing an amazing job with day 1, day 2, day 5, day 7. So I would say this is totally fine. And then eventually the same for my honeymoon. So I think it's doing an okay job. This is literally all it takes to do a manual evaluation. What we're doing here, just as a reminder, it's testing how well is my large language model working. Is the information accurate? Is it in a smooth way? Is it fluent? So a little bit what I just covered in the benchmarking, but now you're going to run through your own manual test. I'm going to save the results because maybe you want to hand this over to your AI team. You want to hand this over to maybe your data scientists. Where now you could also do this in an automated way. So let's go back and continue here. We started with a manual one and now moving over from manual to automated. I could go back to the chat playground and immediately deciding to go for automated. So that would be the same thing. We're now a little twist here. I want to evaluate my environment and I'm going to inject my custom data set. A scenario that we used before, where now it's asking me, like again, a couple of sample questions, looks all good to me. And now based on the four parameters from the benchmarks, we can now identify the same thing. So for this, just to speed up the demo a bit, we have coherence, we have fluency. I'm going to connect it down here to my AI backend. I'm going to use the good old 3.5 turbo model, and that's all it really needs. I'm going to click next, I'm going to click finish, and now it's running an automated evaluation. At the end of the evaluation, it's going to show me a nice looking dashboard that looks quite the same as the benchmark one. Running the evaluation, depending obviously on how much data you're going to inject, might take a little bit longer. And what I used before in a different context is the tracing. Like what are the different steps? What is happening, input, node, output? It's going to be the same thing. So let's give it a couple of seconds and then validating that it's running as it should be. Cool, so with that, our running status has now changed to completed, which means that our automated evaluation, that's what we were doing, is now completely done. And it's going to show us some statistics. Now, I showed you the benchmarking before, comparing all the different models. I would say the outcome here is roughly the same, but it's for your specific model, it's for your specific custom copilot scenario. We're now based on some of our demo information. It's going to provide some feedback, like, well, your custom scenario has a coherence with a value 3, fluency 3, which honestly, I think it might need to do a little bit of a better job. If we have 3 out of 5, I think there's like 2 spaces left to fill up and making our model a little bit more accurate. How would you do that? By, for example, providing more input samples, because remember, I only had like 4 or 5 phrases. Some of them were 100% okay, some of them were not always 100% okay. Well, now for each and every of the sample data, you can again go back to the completion state, and it's going to show you the full technical content of it. So it's going to show you the YAML information. It's going to show you the sample. So this is for our 7-day trip to Orlando. And even on the side, if I make all this a little bit smaller, it's going to show the full evaluation, allowing you to identify in this prompt flow. Yes, this is a prompt flow. It's going to highlight each and every step in the cycle and allowing you to maybe validate where there's room for improvement. Remember, we talk about input nodes, like the processing units, and output, where the new output can become the input for the next step. And that's where you would go through the different steps in the cycle, running manual, running automated evaluations. Pretty cool. I would encourage you to definitely have a look into this and spending some time evaluating your custom copilots. Cool. Now, we're close to the end of this session today. And in the end, I like to go back to the start of the session and really going to the start. And that's the title of the training. It's called Developing Custom Copilots. Where now you could go like, well, Peter, apart from some code snippets in your demos, we didn't really develop anything. Where in this last part, and it's only going to be a couple of minutes, I want to show you, like, with all the knowledge that you gained out of this training, how can I move this into my development mindset? And that's really using or building custom copilots using a code-first deployment approach. Now, what do we mean by code-first? It's really writing code. If you think back about deploying AI Studio, there's no code involved. But it's an important tool. Why? Because without Azure AI Studio, there's no real management interface, or at least not that combined, coherent management interface that you as a developer are going to use, but also your data scientists are using, and maybe your overall solution architects will use as well. Next to that, when we talk to developers, like probably a lot of you here, you think in terms of Azure AI SDKs. Now, the SDKs is where you got the software development kits, right? Where it's going to allow you to easier bring in code snippets into your development language. So if you're writing Python code, if you're writing C#.NET code, if you're writing Java-based code, that's where you have that Azure AI SDK. On top of that, you can use the Jupyter notebooks. Now, Jupyter notebooks are, I would say, the technical building blocks that you mainly see in like a machine learning data scientist approach. So you might think, as a developer, I never really used it before, but maybe in the near future, when you're really building out your AI solution, your AI custom copilot inspired component in your broader solution, right? That's where you might look into writing, creating, authoring Jupyter notebooks as well. Then obviously prompt flow. I would say the concept of prompt flow is not really coding first or code first inspired, but there's some coding inspiration, which means that in the node section of our flow, that's where you bring in the large language models. You need that API integration, but we touched on all that already. But then out of the Python script integration or the Python coding integration, that's where we really expand, augment the capabilities of prompt flow. I'm not saying that you cannot use prompt flow if you're not a developer, but obviously it's beneficial if you understand Python scripts because it allows you to really expand the functionality, the capabilities of your prompt flow. And all that can be integrated into your, I would say, trusted development environments. If we have VS Code, one of our lightweight multi-platform ready development environments, there are extensions for prompt flow as one of the examples. You can expand with Jupyter extensions and writing the code from there and then eventually publishing it into your AI solution. It's about the same in Visual Studio, the good old trusted familiar development environment, and why not even using GitHub Codespaces. If you do not know GitHub Codespaces, it's like a Visual Studio Code-alike scenario running from within the browser. You get access to a hosted environment. It's running on a virtual machine, container-alike scenario in the backend. But the nice thing for you as developers is that you don't have to worry about all that infrastructure. So you're going to use GitHub Codespaces. It's going to give you access to the prompt flow, the Jupyter notebooks, and everything that you need from a traditional developing perspective. Then two other things that we don't touch at all here in this training is semantic kernel and LangChain. Now, in short, what semantic kernel is doing is a lot similar in concept, at least, to the retrieval augmented generation. It's allowing you to inject additional functionality, intelligence, coding pieces into your application to make it more accurate. Where we talked about RAG, we talked about how to use that from within prompt flow, how to use it from within your own data sets, but it's nothing really coding based. Where now with Symantec kernel, it's the exact same concept, building a RAG application, but now looking at it from a coding approach. Then obviously the OpenAI service, if you're using OpenAI as one of the large language model producers, you still have that Azure OpenAI service that you can deploy. You have the OpenAI Studio, but out of all the demos and the explanations so far, you should know that there is no real need anymore to specifically zoom in on OpenAI Studio because it's nicely integrated in the overall Azure AI Studio. And then the large language models, I'm not going to talk about them anymore because that's mainly what the whole topic has been about so far. And then last, the cognitive search, integrating vector search using our Azure AI search as well. So from here, I'm going to walk you through one of my last demos for today and for the whole training, really touching a little bit more on how to use all the components that we talked about before, bringing in again in some of the demo scenarios from before, but now instead of using Azure AI Studio, using the playground, using prompt flow, all from within that studio management environment, how it actually works from within Visual Studio Code. So like I mentioned, I would like to wrap up the whole session, part 1, part 2, and showing you how to bring all the information that I mainly presented out of an Azure AI Studio perspective. How do you bring all that into your, I could say, trusted development environment? So the first example I'm going to use, just because I love it so much, is using GitHub Codespaces. In short, if you don't know what GitHub Codespaces is about, it's running your development environment all from within a browser without needing to install anything on your local machine. So you configure Codespaces, and obviously each and every virtual machine you deploy comes with a cost. Keep that in mind if you want to expand on this. But what I did is, starting from my sample code, it's a fork from our Azure Samples Contoso Chat custom copilot solution. So if you really want to dig in and going through quite a lot of the scenarios I already talked about and showed you, it's not based on the Contoso Chat source code, but it's going to give you about the same experience. Just the data, it's not a travel agent, it's being used in some sort of a retail scenario. So I forked the official Azure Samples Contoso Chat into my own GitHub space, and from there I configured my GitHub workspace. It's already running, so it's running in the backend, a 2-core virtual machine, 8 gigs of RAM, 32 gigs of space. I don't need a lot just for my demo, but just to give you some idea, this could physically replace your high-end developer desktop. The nice thing is that it feels and looks like Visual Studio Code, and my assumption is that a lot of you developers in the audience are super familiar in using Visual Studio Code, and it's literally identical, but it's not running on your local machine. I have my workspace, and within I have all my source code. Now, I'm not going to walk you through all the files in this repo, but I'm going to highlight some of the ones that are mostly related to the context, like our Azure OpenAI scenario, Azure AI Studio alike, and then maybe touching a bit on prompt flow. So I got my data, I got my Python files, and as you know from now, out of the prompt flow scenarios, Python is one of the examples. Now, nothing blocks you from obviously developing your custom copilot using Java language, using C#.NET. Now, to show you a bit how it works, I have my Python scripts over here. It's picking up some information about my Azure environment. I'm pointing to my text embedding, maybe a little bit later on pointing to GPT-3 and whatnot. I'm using variables, Azure OpenAI endpoint, you need the API key and all that cool stuff. I have an extension for prompt flow. And again, I didn't really need to install this myself. It's all coming out of that workspace. And what I can do from here is literally replicating everything I showed you before in AI Studio. So it's going to pull up the list of flows. It's just refreshing, I guess. It's going to allow me to create a new flow. So I'm not going to wait for importing or recognizing the existing one. Let's start with creating a new flow. 100% the same as what I did in AI Studio before. I can create an empty flow, but that's not too exciting. I'm going to create a standard flow with a template. and I can do the evaluation. Remember one of the steps in the previous demo, or using chat flow with a template as well. So let's do a simple chat flow. I'm going to configure it. It's going to create its own little space, creating the prompt flow files. And from here, it's now building up a new environment. Again, it's almost identical to VS Code, and it's giving me my little prompt flow steps as well. I'm going to give it another little bit of time. I have my chat request Python script, again, just a template. I got my AI search. Remember, if you're integrating indexing, it's already there as an example. We have the YAML file, the setup, where we have the input, we have the questions, customer ID in this case, just again, an example. I can move over once more to my prompt flow. And the cool thing here is that now out of my development environment, it's going to give me an almost identical interface to my web browser, Azure AI Studio. I can do everything the same as before, but I'm not going to walk you through the actual examples because you already know how all this works. But again, this is bringing it all into your trusted development environment. So flipping around the mindset of the virtual training day, maybe I should have started with, this is your development environment today. This is how you can integrate using prompt flow as an extension, using Python as an extension in Visual Studio Code, and then eventually showing you what it looks like in AI Studio. I like to flip it around because I'm pretty sure that a lot of you are teased by maybe leaving your development environment a little bit, because in the end, you might not really need it as such anymore. Now you might go like, well, that's fine, but I'm not running GitHub code spaces. Well, that's totally okay. You have your repo, you're going to fork it to your local machine, and you have the exact same outcome. So this is now running on my local machine. I know it looks weird because it's almost identical to the GitHub workspaces, but it's on my local machine where, again, I have my flow. I have the new flow. I can open it. I can test it. Let's give it a test. I can now test it in interactive mode, where now it's mimicking the chat completion. To do this, if you're using Visual Studio Code today, you need to install the prompt flow extension. You need to install the Python extension. You need to add some specific prompt flow components, but it's all nicely written out once you start deploying that extension. Next to that, you need your connection. So that's the other step. I have my input, have my output. I configured my chat completion connection settings, where now I can ask again, can you tell me what to visit in Seattle? And it's even succeeding in completing that. This is not a fine-tuned model. This is not a customized system prompt. I didn't do anything of that. But the nice thing is that from here, you could actually run all the AI testing, the prompt flow configurations, the developing your custom copilots on your local machine. And then eventually from here, you would move this into a published application. So you could use build from here. As a developer, you should close with building your application, right? Validating if the code is working, if the functionality is there. Building it as a Docker container, you could export all the config files out of your source code, moving that into your AI Studio, instead of building it over and over from there, importing the text files, the config files, the application solution files, and that would be pretty much it. So with that, we're at the end of this demo. We're at the end of the last demo that I promised, hoping that it gives you a good idea about everything we talked about in part 1 and 2 can now be moved into your own development environment, stimulating collaboration in the same way developers, DevOps teams have been collaborating over the years, and nothing's really changing with AI Studio. Back to the last closing of the presentation. So with that, we're at the end of this part of session 6, where it started with exploring the evaluation of custom copilots. Think back about using the benchmarks out of Azure AI Studio. Next to that, I also talked about the manual evaluations of our flows, and then eventually moving over to how to automate it, watching over the metrics, and learning how to evaluate the success of our tools, and then maybe, if still needed, fine-tuning them a little bit. This concludes our session. Now, there are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at ak.ms/learn.